Hello everyone, in today's video we'll be going over a bunch of practice problems on geometric sequences. So the previous video was the lesson for this video essentially. So if you've already watched that, then welcome to this video. We'll be going over the problems. So I want to start by first writing out two of the formulas that we will need, actually the only two that we will need, and these are the ones that we went over in the last video. So first of all, the common ratio is an over an minus 1. So to find the common ratio, we take any term and we divide it by the previous term. And the nth term in a geometric sequence is a, the first term, times r to the power of n minus 1. Okay, let's go over these problems now. Okay, so the first one says identify if the sequence 3, 9, 27, 81 is geometric. If yes, find the common ratio. So something is geometric if to get the next term we multiply by a specific number, and if that multiple or common ratio is constant throughout the whole sequence. So here we can see every time these terms are being multiplied by 3. So yes, it is a geometric sequence and the common ratio is equal to 3. Okay, next one. Here we can see that we're dividing by 3 every time, or multiplying by 1/3, we could say, right? Multiplying by 1/3 is the same as dividing by 3. So yes, it's geometric. The common ratio is 1/3. And it also says to find the 8th term here. So we're going to use our nth term formula. So to find the 8th term, we take the first one, multiplied by the common ratio of 1/3, raise it to the power of 8 minus 1. So A8 is equal to 81, 1/3 to the power of 7. And now we have to evaluate this. Okay, so these problems, some of them are, the numbers are a little bit big, so it's a good idea to have a calculator handy, but I've designed these so they can all be done by hand. You just have to keep things in fraction form. Okay, so let's have a look at this guy. So this is going to be 81, and then 1/3 to the power of 7 is the same as 1 to the power of 7 over 3 to the power of 7. 1 to the power of 7 is just 1, and 3 to the power of 7 is 2187. And we're going to notice that both the top and the bottom are divisible by 3. They're actually both divisible by 9 as well. And if we simplify this fraction, we get 1 over 27. So that's the 8th term. So I got this by just dividing the top by 81 and also the bottom by 81. We can simplify this fraction essentially by dividing by 3 and checking to see if we can simplify more. Okay, so let's have a look at the next one. It says for this sequence, find the common ratio and the 12th term. So the common ratio, by now we're experts, it's being multiplied by 2 every time. And the 12th term, so A12 is equal to the first term times the common ratio of 2 to the power of 12 minus 1. So A12 is 5 times 2 to the 11. And once again, you can do this with your hand. So 2 to the power of 10 is 1024, which means 2 to the 11 is 10,000 or 2048 times 5. So you could definitely figure out what that is by hand, but I'll just multiply this with a calculator. So this will come out to 10,240. That's the final answer for this one. Let's look at the next one. It says calculate the seventh term of the geometric sequence where a1 is 2 and r is 4. So the seventh term is our a term, which is 2 times the common ratio to the power of 7 minus 1. So a7 is 2, 4 to the 6. So let's see, 4 to the power of 6 times 2. The seventh term comes out to 8,192. All right, let's go on to the next problem. It says find the missing term. For the sequence 3, and then the second term, third term, all the way up to the 8th term. The 8th term is 6,561. Find the common ratio. Okay, we'll start with our nth term formula, which is this. Now we'll plug in the values, the unknown values here. And by the way, as always, you guys should be pausing the video and trying all of these problems before I show you the solution, because that's how you really can learn in math. Okay, but I'm going to assume you guys have already done that, so here comes the solution. We know the 8th term is 6,561. So 6,561 is the 8th term, and so that's equal to a, the first term, times the common ratio, which we're trying to find, to the power of which term is this, which term is this, the term that we plugged in? That's the 8th term, right? So we're going to plug in 8 minus 1 here. Okay, so 6,561 is equal to 3 times r to the power of 7. Okay, I'll divide both sides by 3, and we'll get r to the 7 here. So let's see, 6,561 divided by 3, that's equal to 2,187, and that's equal to r to the 7. So how can we solve for r? Well, we'll have to take the 7th root to calculate r. And again, this we can do by hand, but that's not the point of this video, so I'll just use a calculator for this. So we'll take the 7th root of 2,187, which will be 3. And so the 7th root of r to the 7 is, of course, just r. So our common ratio is 3. Okay, let's have a look at the next problem. It says in this sequence, the 6th term is equal to 4. Find the common ratio and the general term Tn. And remember that Tn and An are interchangeable. Okay, first the common ratio. So we'll use the same exact strategy. I know that the 6th term is 4. The first term is 128, the common ratio we're trying to find. And this is the 6th term, so we do 6 minus 1 here. So I'll divide both sides by 128. So we'll get 4 over 128 is equal to r, and then 6 minus 1 is 5. And next I'll take the 5th root of both sides, right? So if we take the 5th root of both sides, 5th root and power of 5 cancels out, we get r is equal to this. So now I'm just going to plug that entire thing into my calculator. 4 divided by 128, and we want the 5th root of this, which will be 1/2. Okay, so r is equal to 1/2. So now that we have r, we can find an expression for the general term. So an expression for the general term will be Tn is equal to our first term, 128, times the common ratio to the power of n minus 1. So this is the general term expression. Let's have a look at the next one. It says, given the sequence and that the fifth term is 6,250. Find the common ratio and the third term. So we'll find the common ratio exactly the same way. So I'll start doing these a little bit faster now. First term, 10 times common ratio, and this is the fifth term, so we do 5 minus 1. I'll just write that as a 4 right now. Okay, divide both sides by 10. If we divide both sides by 10, we get 625 is equal to r to the 4. We'll take the fourth root of both sides, and the fourth root of this, if I'm not mistaken, should be 5. Let's just double check. Yes. So r is equal to 5. All right. Now we want to find the third term. So we'll use our nth term formula, right? I'm talking about this formula. So a3, the third term, will be the first term, a, times common ratio 5. And we want the third term, so we do 3 minus 1 here. So a3 is 10, 5 to the power of 2. So 5 squared is 25 times 10. This will give us that a3 is 250. Okay, so that's the answer for this problem. Okay, let's go on to problem 3. Things will get a little bit more interesting here. So it says for the sequence given, this one, find the formula for Tn and determine the number of terms in the sequence. Okay, so yeah, we've done a bunch of problems where we have to find the number of terms. So hopefully you guys remember the technique we use. The algebra will be a little bit different because this is a geometric sequence, but the idea behind it is the same. So I'll just briefly remind us of that. If this is the first term, and this is the second term, and this is the third term, and we have some number of terms, and let's say the last term is the 20th term, right? Well, if we figure out which term the last term is, right? If we figure out which term number the last term is, then we figured out how many terms there are, right? Because if the last term is the 20th term, then there's 20 terms in total. So our goal is to figure out which term number the last term is. Okay, how can we do this? Well, first, let's find a formula for Tn. Well, Tn, or An, again, they're interchangeable, is equal to the first term, 2, times the common ratio. What's the common ratio here? 2 times 3 is 6, and 6 times 3 is 18. So the common ratio is 3, and we have n minus 1. So this is the general term expression. Now let's find how many terms we have here. Well, we know that, so we don't know that that's the 20th term. We know that our nth term is 4,374. Okay, we know the first term is 2. We know the common ratio is 3. I don't know which term number this is, right? It's the nth term. So we're just going to leave it as n. Okay, as n minus 1. So now we're going to have to solve this. First, I'll divide both sides by 2, by this 2, right? So 4,374 divided by 2. If we divide both sides by 2 to simplify, we get 2,187. This is equal to 3 to the n minus 1. Okay, just to be clear, what we did there is divide both sides by 2, and these 2's canceled out. Okay, so right, now the question is, how do we solve this? There's a method that we'll learn later using logarithms, but I haven't done a video on that, so I'm going to show you guys another method, something that you learn in grade 10. Okay, the right-hand side is a number that is a power of 3. Okay, so it's, or I should say, the right-hand side is a number that's 3 to the power of something, right? So it's some number of 3's multiplied together. So what we have to do in this problem to solve for n is we have to express this number so that it also has a base of 3. Okay, so I have to write this as 3 to the power of something. So how do we figure out what that is? Well, we're going to have to do the prime factorization of 2187. So 2187. Let's see if this is divisible by 3. The way you check divisibility by 3 is if we add all the digits here. And so let's see, what is the sum of all the digits here? 8 and 7, that's 15. 15 and 2, 17. 17 and 1, 18. And if the resulting number, so 18, if that's divisible by 3, which it is, then the original number will also be divisible by 3. Okay, so we know that this number is divisible by 3. I'm going to divide this by 3 and see what I get. I get 729 here. 729 is also divisible by 3. So if we divide it by 3, we get 243. And I'll actually divide this one by 9. So we get 9 and 27. 9 is 3 and 3. 27 is 3 3's multiplied together. So long story short, we can tell that 2187 is equal to 1, 2, 3, 4, 5, 6, 7 copies of 3. So this is 3 to the 7. So I can write 3 to the 7 is equal to 3 to the n minus 1. Okay, where do we go from there? Well, if you have two things that are equal, the right-hand side and the left-hand side are equal, and the bases, right, if they're exponent and the bases are equal, that must mean, in order for the right-hand side to be equal to the left-hand side, that the powers also have to be equal. So we can say that 7 is equal to n minus 1, meaning n is equal to 8. So there are 8 terms in this sequence. Okay, that's the answer for this one. Let's look at the next problem. So the next problem is just like the top one, except with different numbers. So this is going to help us get practice. Okay, let's have a look at it. I'll go through it a little bit faster. What's the general term expression? General term expression is Tn is 1024. What's the common ratio? It seems like the terms are getting divided by 2 or multiplied by 1/2, and then we have n minus 1. Okay, we need to figure out which term number 1 is, and because if we do that, we can figure out how many terms there are. Okay, so we're going to plug in 1. So we have 1 is equal to 1024, times 1/2 to the n minus 1. Divide both sides by 1024, we get 1 over 1024 is equal to 1/2 to the power of n minus 1. Okay, now, so we're going to do this the same method as before. We have to write both sides so that both sides are written in terms of a base of 1/2. So I want 1 over 1024 to be written as 1/2 to the power of something. Okay, so maybe you guys remember this one as well, but 1024 is 2 to the power of 10. Okay, so I can write that this is 1 over 2 to the 10, which is the same as just 1/2 to the power of 10. And that's equal to 1/2 to the n minus 1. Again, if the bases are equal, the exponents here also have to be equal in order for the right hand side and left hand side to be equal to one another. So we get that n minus 1, or sorry, 10 is equal to n minus 1, meaning n equals to 11, and we have 11 terms. All right, so let's go on to number 4. It says find the number of terms in the following geometric sequence. So the next few problems here are just meant to be practice, so we can practice the technique we used above. So please go ahead and try this on your own first, and once you've given it a try, unpause the video and watch the solution. So here we go. Exact same method. I'll do it a little bit faster than last time, or than the first time, just because we know the explanation now. So 1024 is equal to, we want to figure out which term number this is, right? So we're going to set it equal to the first term times the common ratio, which is 4 to the power of n minus 1. So the 1 here doesn't really matter. We can even remove it. So we need to write the left-hand side in terms of something with a base of 4. Okay, so what is that going to be? I think 1024 is the same as 4 to the power of 4. Let's see. No, it's 4 to the power of 5. Yeah. Okay, so we can rewrite this as 4 to the power of 5. If you didn't know that 1024 was 4 to the power of 5, how could you do this? Well, same way as we did in the original problem. You can do the prime factorization, and well, not quite the prime factorization. You have to keep dividing this by 4 because we want the base to be 4. So we would take 1024 divided by 4. That's going to give me 256. I'm going to divide that by 4 again. That's going to give me 64. Divide, oops, not multiplied. Divide that by 4 again. That's going to give us 16. Divide that by 4 again. We get 4 and 4. So we have 1, 2, 3, 4, 5 4s. 4 to the power of 5 is equal to 1024. That's how you get that number. Okay, so it's all done using this division tree setup. All right, so let's erase this. All right, anyways, let's get back to it. So this means that we have 5 equals to n minus 1, which means n equals to 6, and we have 6 terms. All right, let's have a look at the next one. 1 over 27 is equal to 81. Common ratio here is 1/3 because they seem to be being multiplied by 1/3 every time to get to the next term. And we have n minus 1 here. So here we'll have to divide both sides by 81. So let's see. 1 over 27 divided by 81 is the same as, because 81 is the same as 81 over 1, right? You can always put a denominator of 1 under anything. So divided by 81 is the same as multiplied by 1 over 81. And fraction multiplication, you just multiply the top by the top and the bottom by the bottom. So long story short, in order to divide both sides by 81, you just have to multiply 81 and 27 and put that in the denominator. So this is equal to 1/3 to the n minus 1. And I have to rewrite 1 over 2187 as a power of 1/3. Or more simply, I have to write 2187 as a power of 3. So we can do the prime, not prime, but the factor tree. But I think I can take a good guess at this. I think this is going to be 7. Yes. So this is the same as 1 over 3 to the 7. Okay, which means we can rewrite this as just 1/3 to the 7 is equal to 1/3 to the n minus 1. Okay, now that means 7 is equal to n minus 1 and n is equal to 8. So there are 8 terms here. Okay, let's have a look at the last one for this section. Same method. So we're going to have 125 over 64 is equal to, again, why are we plugging this in? Because we're trying to figure out which term number this is. Once we figure out which term number this guy is, that's going to be equal to the number of terms we have in this sequence. Okay, so we do 125 over 64 is equal to 1000 times the common ratio is 1/2 here, right? Every time everything's being cut in half, right? So it's being multiplied by 1/2 to the power of n minus 1. So let's go ahead and divide both sides by 1000. So that's going to be the same as using the fraction multiplication logic on top. It's going to be 125 over 64,000. I encourage you guys to pause the video, do this by hand, make sure you agree with this. Okay, to the power of n minus 1. So let's see, can we simplify 125 over 64,000? We should be able to do that because they're both divisible by 5, right? So I will do that with a calculator. So that fraction simplifies to 512. Again, verify it yourself. Make sure you agree with what I'm writing down. Okay, and we have to write this now, write this as a number with a base of 1/2. So if I remember my powers of 2, 512 is 2 to the power of 9. So let me just double check this, 2 to the power of 9. Yep, that's 512. So this is equal to 1/2 to the n minus 1. Now, 1 over 2 to the 9 is the same as 1 over 2 whole thing to the 9. Okay, so that means 9 is equal to n minus 1, and n, adding 1 to both sides, is equal to 10. So that means in this sequence, we have 10 terms. All right. So let's look at some word problems now. So we have that a car is worth 30,000 and loses 20% of its value each year. What will be the car's value after 7 years? And we want to use geometric sequence reasoning. Okay, so I'm a visual person, so I'm gonna draw some stuff out first. So first, it's the car. So what do we want to find? What will be the car's value? Okay, we want to find the car's value. So the car is initially $30,000 and it loses 20% of its value, right? So what is 20% in decimal form? That's 0.2. To go from percent to decimal, you simply divide by 100. Okay, so the value of the car initially is 3,000. What is the value of the car after the first year? Well, it's lost 20% of its value, so it's retained or kept 80% of its value, right? So after the first year, the car is going to be worth 30,000 times 0.8. So this means it's worth 80% of 30,000. Okay, after another year, so it's going to lose another 20%. So that means it's only going to retain 80% of this quantity. Okay, so we're going to take this quantity, 30,000 times 0.8. So that's the amount we had here. and we're only going to keep 0.8 or 80% of it. So we can see that the common ratio here is 0.8, right? Every time we're multiplying by 0.8. Okay, now one important thing to note. This is the first term, this is the second term, and that's the third term. We want to know what the value of the car is after 7 years. So we don't want to find the 7th term here. We actually want to find the 8th term here. Why? Because our second term here is the value of the car after 1 year, right? So this is the initial value. This is before sort of the timer starts going, right? This is the value after the first year. This is the value after the second year, right? So our third term is the value after the second year. So if we want the value after the 7th year, we actually want to find the 8th term. So that's what we're going to do. So A8 is going to be the first term, which was 30,000, times the common ratio. We talked about how that's 0.8, and we want the 8th term. So 8 minus 1. So A8 is equal to 30,000 times 0.8 to the 7. And I'm going to figure out what this is with my calculator. 30,000. So this is going to come out to 6,291.456, so around to $46. Okay, so this is the value of the car after 7 years, assuming that it depreciates by 20% each year. All right, hopefully that made sense. If not, you can always leave your questions in the comment section or rewatch how we did that. Okay, let's have a look at the second one. It says a population of insects triples every week. If there are 200 insects initially, how many will there be after 5 weeks? So 200 initially. After the first week, we're going to have 200 times 3. After another week, this population will be tripled. So it'll be 200 times 3 times 3. After another week, this population will be tripled. So it's going to be multiplied by 3 again. Okay, so we can see the common ratio is 3. It's being multiplied by 3 every time. All right, now, same reasoning as for the last problem. This is the first term, this is the second term, this is the third term. This is the population after 1 week. And this is the population after 2 weeks. So our third term is the population after 2 weeks. If we want the population after 5 weeks, we're going to have to find the 6th term. Okay, so, and the reason for this is because we're starting with the initial value, right? 200. 200 is sort of the population before they start multiplying. So that's why we are finding one more. Okay, so the 6th term is 200 times the common ratio, which is 3 to the power of 6 minus 1. So A6 is equal to 200 times 3 to the 5. So this is going to be a pretty big number, I think. Let's see what it is, times 200. Yeah, so if they start out at 200, after 5 weeks, we're going to have 48,600 insects. So that's a lot. All right, next problem. It says an investment of 5,000 grows by 10% each year. How much will the investment be worth after 10 years using geometric sequence reasoning? Okay, so there is sort of maybe one new concept here that we'll learn. So let's draw this out. So initially we have 5,000. And after 1 year, we're going to have 10% more money. So what does 10% more money mean? It means we have our original 5,000 plus 10% of 5,000. 0. And I'll write the decimal version, right? So divide this by 100. Oops, divide. And we get 0.1. Okay, so what is 500 plus, or sorry, 5,000 plus 5,000 times 0.1. So again, the reason we have this is we have our original money and the interest, right? The profit of 10%. So if we take this and factor out 5,000, we get 1 plus 0.1, which is equal to 5,000 times 1.1. So in interest problems, if you're making a profit of 10%, you're keeping the original starting amount of money, we would represent that as 1.1. So it's always whatever the interest is in decimal plus 1. If our interest was 5%, we would have 0. Or 1.05. If our interest was 20%, we would have 1.2. If our interest was 7%, we would have 1.07. Okay, if our interest was 25%, 1.25. Okay, so instead of that, I'll just write 5,000 times 1.1. Okay, how much money are we going to have the next year? Well, the next year we'll have whatever this amount is, which is 5,000 times 1.1 times another 10% profit. So times another 1.1. Again, why 1.1? Because we keep our original amount of money, that's the 1, and we make 10% profit. So that's the 0.1. Okay, so we can see the common ratio is 1.1. And same logic as before. This is the first year. This is the first term. This is the second term, and this is the third term. The second term is the amount of money we would have after 1 year. And the third term is the amount of money we would have after 2 years. So if we want the amount of money after 10 years, we'll have to find the 11th term, right? One more. So A11 is equal to 5,000 times the common ratio of 1.1 to the power of 11 minus 1. So we have A11 is equal to 5,000, 1.1 to the power of 10. So A11 is equal to 5,000. And let's see what 1.1 to the power of 10 times 5,000. So that's going to be equal to 12,968.71. Okay, so that's going to be how much money this person would have in 10 years. All right. Let's have a look at the next problem. So it says the third term of a geometric sequence is 54 and the sixth term is 1,458. Find the first term and the common difference. This is going to be very similar to, we're going to use a similar technique as when we did the arithmetic series stuff. So the first term in this geometric sequence will be A. The second term will be AR. The third term will be AR squared. And the fourth term will be AR cubed, and so on. So this is the first term, second term, third term, and fourth term. So can we predict what the sixth term is going to be? Pattern here is that our fourth term has r cubed, our third term has r squared, our second term has r to the power of 1, right? So we can write down the following. The third term should be ar squared, and we already wrote that down. That's equal to 54. And the sixth term should be ar to the power of 5, right? Just by looking at the pattern. The sixth term, so the fourth term is r to the 3, right? ar to the 3, 1 less. So the sixth term will be ar to the 5, 1 less than 6. And that's equal to 1458. Okay, we have two variables. We don't know a, we don't know r, but we also have two equations. So we can solve for both a and r. We're going to do this using substitution. So I'll first solve for a in the first one. So a is going to be, if we divide both sides by r squared, we get 54 over r squared. And now I'm going to take a and plug it into the second equation. So instead of a, we'll write down 54 over r squared times r to the 5 is equal to 1458. Okay, so let's simplify this. I'm going to erase these guys. And let's continue. Let's actually erase these as well. So we are at 54 over r squared. I shouldn't have erased that. We're going to need that later. So let's just maybe instead continue here without erasing anything. So we have 54 over r squared times r to the 5 is equal to 1458. We can cancel 2 of the r's on top with 2 of the r's on the bottom. So that's going to give us 54 r cubed is equal to 1458. If we divide both sides by 54, what do we get? 1458 divided by 54. So we get r cubed is equal to 27. So that was after dividing by 54 on both sides. And now we have to take the cube root of both sides to solve for r. And that's going to give us that r is equal to r is equal to 3. And meant to do that in green. R is equal to 3. So that's our common ratio. We found our common ratio. How can we find the first term, right? Because they were asking for the common ratio on the first term. Well, we can just plug it into this equation or any of our initial equations, right? But I'll plug it into this. So let's write this more compactly. R is equal to 3. And now we're going to plug that into this 54 over 3 squared. So we get that a is equal to 54 over 9. And so let's write this out. Is equal to 54 over 9, which is equal to 6. Okay, so that's our r common ratio as well as our first term a. So maybe we'll just write a equals to 6. All right, let's have a look at the next one. So it says in a geometric sequence, the fourth term is 16 and the seventh term is 128. Find the first term and the common ratio. Okay, same drill, same method. This time we'll jump the initial step and go straight to the equations, right? If you have any concerns about the method, you should go back and review how we did the first problem 4. So let's have a look. The fourth term is 16, so that means ar to the 3, right, will be equal to 16. Because remember, the power of r is always 1 less than the term number. So if we want the fourth term, we're going to have to write ar cubed. And the seventh term is 128. So ar to the 6 is 128. Same drill. We're going to solve for the equations here. And we'll do that by first solving for a in the first one and then plugging it into the second one. So a is equal to 16 over r squared here. Plugging in a here, we get 16 over r squared times r to the 6. Oh, that should have been r cubed. We're dividing by r cubed on both sides. All right. So times r to the 6 is equal to 128. All right, so now let's grab this and simplify it. I can cancel out 3 of the r's on top with 3 of the r's on the bottom, so we get 16 r cubed is equal to 128. Divide both sides by 16. So let's see, what is 128 divided by 16? That's going to be 8, and then we're going to have to cube root both sides to get that r is equal to 2. Okay, so we have that r is equal to 2 here. Now we're going to have to solve for the first term. So how can we do that? Well, we can plug it into this guy. Again, you could also plug it into any of these first two equations. Okay, so we know that a is equal to 16 over 2 cubed. So a is equal to 16 over 27. And what does that simplify to? 16 over 27 is just going to stay as 16 over 27. Is this right? Let me... Oh, sorry, that's not 20. That's 2 to the 3. That's 8. I did 3 to the 3 by accident. So that's going to be 2. So our a is 2. Okay, common ratio is 2. First term a is also 2. All right, so now we are in the advanced problem section. Not much more difficult than the word problems we did, maybe a tiny bit more interesting. So let's have a look at them. The fourth term of a geometric sequence is 16 and the ninth term is 512. Find the first term and the common ratio, then determine the 12th term. Okay, so the beginning of this problem is going to be the same as the word problems we did above. The fourth term is 16. So that means AR cubed is 16. Was it 16 in the previous problem? Yeah, it was also 16 in the previous problem. Okay, but this time we're talking about the ninth term instead of the seventh term. And the ninth term, AR to the 8, is equal to 512. So now we're going to solve for A in the first equation. A is equal to 16 over r cubed. Plug A in into the second equation. So if you plug A in into the second equation, we get 16 over r cubed times r to the 8 is equal to 512. Okay, let's clean this up. So this guy becomes, cancel 3 of the r's on the top and bottom. So we get 16 times r to the 5 is equal to 512. Divide both sides by 16. And we get r to the 5 is equal to 512 divided by 16 is 32. And the fifth root of 32, fifth root of both sides, and fifth root of 32 is 2. Okay, so the common ratio here is going to just be 2. So let's go ahead and find the first term. So I'm gonna erase all of the, not all of this. I'll erase everything except for this guy, which we will need. So our r value is 2, and our A will be 16 over 2 cubed. So we're going to get the same number as before, right? A is equal to 16 over 8, which is 2. So our A value is also equal to 2. Okay, now it's asking us to calculate. I'm going to erase this now. Now it's asking us to calculate the 12th term, and we know how to do this, right? The nth term formula. So A12 is equal to first term, 2, times the common ratio of 2 to the power of 12 minus 1. So A12 is equal to 2 times 2 to the 11. And let's see what this comes out to. So 2 to the power of 11 times 2, that's going to be 4096. So that's the 12th term. All right, now we are on to the last problem. Let's have a look at this guy. It says the second term of a geometric sequence is 3 and the fifth term is 375. Find the first term and the common ratio, then determine the 8th term. Okay, so this should be pretty familiar by now. Let's go ahead and solve it. So the second term is AR to the 1, or just AR, and that's equal to 3. And the fifth term is AR to the 4, and that's equal to 375. Find the first term, common ratio, and the 8th term. So let's go ahead and find the first term and the common ratio. Same drill as before. System of equations, 2 equations. We have 2 unknowns, so we need at least 2 equations, and we have 2 equations. We'll solve for A in the first one, plug it into the second one, and go from there. So A is equal to 3 over R, and we'll plug that in here, and we'll get 3 over R times R to the 4 is equal to 375. Okay, now we're going to simplify that. So we have 3. I'll just cancel one of the r's from the bottom with one of the r's on top. So we'll end up getting 3r cubed is equal to 375. Let's divide both sides by 3. So we get r cubed is equal to 375 divided by 3. That's 125. Okay, take the cube root of both sides, and cube root of 125 is 5, so r is equal to 5. Okay, now let's find the a, and we can just use that. So our a will be 3 over r, which is 5. So let's maybe write all of our answers over here. So our r value is 5. Our a is 3 over 5. And we want to determine the 8th term. So how can we find the 8th term? We'll use our an formula. So a8 is equal to the first term, which is 3 over 5, times the common ratio of 5 to the power of 8 minus 1. So A8 is equal to 3 over 5 times 5 to the 7. Okay, before I put this in my calculator, I'm just going to notice I can cancel one of the 5s on the bottom with one of the 5s on top. So this will become A8 is equal to 3 times 5 to the 6. So let's see what this is. 5 to the power of 6 times 3, and our 8th term is equal to 46,875. So A8 is equal to 46,875. Okay, so that's going to be it for this video. I hope you guys found these problems helpful. If you have any questions about anything, any of these problems or the lesson, please feel free to put it in the comment section and I'll do my best to get back to you guys. All right, see you guys in the next video.